This is Electric Universe Eyes, and today I'm going to narrate a paper written by Alexandra Teste, posted on the Annals Geophysica 2007, titled Cluster Observations of Electron Outflowing Beams Carrying Downward Currents Above the Polar Cap by Northward IMF. Abstract. Above the polar cap, at about 5 to 9 Earth radii altitude, the PEACE experiment onboard cluster detected for the first time electron beams outflowing from the ionosphere with large and variable energy fluxes, well collimated along the magnetic field lines. All these events occurred during periods of northward or weak interplanetary magnetic field (IMF). These outflowing beams were generally detected below 100 electron volts and typically between 40 and 70 electron volts, just above the photoelectron level. Their energy gain can be explained by the presence of a field-aligned potential drop below the spacecraft, as in the auroral zone. The careful analysis of the beam's distribution function indicates that they were not only accelerated, but also heated. The parallel heating is estimated to be about 2 to 20 electron volts, and it globally tends to increase with the acceleration energy. Moreover, WISPR observed broadband electrostatic emissions around a few kilohertz correlated with the outflowing electron beams, which suggests beam-plasma interactions capable of triggering plasma instabilities. In presence of simultaneous very weak ion fluxes, the outflowing electron beams are the main carriers of downward field-aligned currents, estimated to be about 10 nanoamperes per square meter. These electron beams are actually not isolated, but surrounded by wider structures of ion outflows. All along its polar cap crossings, cluster observed successive electron and ion outflows. This implies that the polar ionosphere represents a significant source of cold plasma for the magnetosphere during northward or weak IMF conditions. The successive ion and electron outflows finally result in a filamented current system of opposite polarities, which connects the polar ionosphere to distant regions of the magnetosphere. For more information, you can find this posted on academia.edu. The link will be in the description.